All right, and now we have our last video for Unit 4. Our first question asks us to identify the coordinates of this parallelogram. Well, obviously, this first corner one is at the origin, is at 0, 0. The other ones are arbitrary, and what I mean by that is we kind of get to pick what they are. But how far one is from another will affect the other pieces. So this is what I mean by that. Whatever this distance from here to here is, let's call it C. This distance, how far up we're going, is going to be the y value of this point. So I'm going to call that purple one something C. Now again, whatever this distance from here to here is going to be the x value of that point. Let's call that distance D. So we'll call this the point DC. We're going up C amount and over D amount. Now this point way over here has to be just as high as this point. So it has to be up C amount, just like the other one. So that one, the y value has to be C. How far over it is, though, kind of depends. We don't know that one yet. Let's work on this piece here. Now, again, because this is a parallelogram, all of these are parallel. That means this side is the same length as this. This is the same length as this. So, from this point to this point, we would say this distance, again, we can make it up whatever we want. Let's call it A, is going to affect this point here. Say it was A, so this would be at the x value, A, and its y value, well, it's right on the x-axis here, so it's not up any, so it's 0 for a y value. So if this one was at A0, and to go from here over this amount to get up here, has to be the same as here to here, right? Because this slope has to be, has to be the exact same as this slope because they're parallel. It's a parallelogram. So over and up has to be the same amount as this over and up. So here to here, this x distance has to be the same as that. So this x distance was A. Here to here is another D amount. So this x value has to be A plus D. Okay, so we can take each of those pieces, not everything. I just want this. This would be this corner one over here. This would be the red spot right here. This one, instead of moving everything, we're just going to readjust or draw them. DC is right here, and A plus DC is this top one up here. Okay, and again, they're arbitrary, meaning this one we know is 0, 0. Everything else depends on the distance from that because it's a parallelogram. So we can call those values whatever we want, but the distance from here to here is the same as the distance from here to here. The distance from here up is the same as the distance from here up. Has to be because it's a parallelogram. Let's look at our last one then. This one will get kind of goofy. We're using the same ideas as our last problem, that number 4, and looking at these saying, all right, this is at 0, 0, this is at A0. So we weren't given an actual value, this is a variable amount. Same thing, this is 0, 0, this is DC. Now because this is a trapezoid, not a parallelogram, this distance doesn't have to be the same as this distance from here to here. Okay, it's not necessarily going to be the same exact distance because it's a trapezoid, not a isosceles trapezoid. So we don't know for sure if that's going to be the same. With that in mind, we need to find a couple features of this, couple properties. So instead of going to these lengths, I'm going to start first with the slopes from B to A. Okay, again, we're not on a straight line necessarily, so it'll be hard to to count. We don't have all these tick marks, but we know that if our y value is c and this y value is 0, that means we're going down c amounts. So the top value is going to be negative c. That's, again, here to here, we're going down c. So from here to here, then, how far over are we going? Well, that depends on where b is at and where a is at. If we know these numbers, we would say, all right, take this letter A, subtract letter B, and that's how far this would be. So we would call that A minus B on bottom. So the slope from B to A is going to be negative C over A minus B. Whatever these values are will change that slope there. So the next one we need to look at is the slope of CO. So this piece right here, going from O up to C. Well, this one is a little bit easier. We have 0 and 0, so we're going up a certain amount, and we're going over a certain amount. From here to here, how far up are we going? Well, again, that's just C. We're going up C amounts. How far over are we going? That's D. We're going over D amounts. So we would say the slope is positive C over positive D. Looking at these two slopes then, what does this prove? Well, it proves that B and A, or BA, this line, and CO, this line, cannot possibly be parallel. Okay? These are not the same thing. So there's no way that these would ever be parallel lines. And looking at this, yeah, that's true. There's no way that this line would ever be parallel to this. It's not possible for that to happen. Could they possibly be perpendicular? Well, they could be only if C was the same as D, and that was the same as A minus B. Because this one is a negative version of, or we have a negative C up here, but for it to be perpendicular, it needs to be opposite and a reciprocal. So this one would have to flip everything around. D right here would have to be the same as C, and this C would have to be the same as this AB. So all of these amounts would have to be the same. This and this would have to be the same as this and this. If that were true, if they were all the same amount, then those lines would be perpendicular. But only if that is true. Moving on from there. Now let's change our focus from slope to length. The length of CB going from here to here. Well, these are both on the line y equals c. There's a straight horizontal line right here, and they're both on that line because the y value is the same. It is c. So to find this length, we would take this value x, b, and subtract off this value, d. So we would say the length is just b minus d. Similarly, because O to A is on a straight line, we know that because they both have a y value of 0, then we would just take this x value, A, minus this value, 0. A minus 0 is A, so that length is just going to be A. So we have this length and we have this length. We also need to find the midpoint P. Remember, midpoint is going to be the average of the two points at each end. So D plus 0 is D divided by 2. We would have D over 2 is the X value at this point. Same thing, we want the average Y value. C plus 0 is C divided by 2 is C over 2. So this midpoint P would be at the spot D over 2, comma, C over 2. And remember, that's a coordinate point, one of these points on the grid right here. Midpoint Q. This one's going to be a little trickier. Let's do the Y value first. C plus 0, and then divided by 2. Well, that one's a little bit easier. C over 2 is going to be the Y value of this point. Now, if this one is B and this one is A, and we want in between them, or we want to find the average of those ones, we would say that that would be at the point A plus B. So this value plus this value divided by 2 would find this x value. So a plus b all over 2. This would be one midpoint. This would be the other midpoint. So now that we know the two midpoints, we can find the distance from P to Q. We can find how long that mid-segment is. So we'd have to use, in a sense, we'd have to be using the distance formula, but look at the fact that they are both on the same y line. Right? They're on a straight line right here because both of them are at c over 2 and c over 2. Just like these were both at 0, so we could just count over. These were both at c, so we could count over. These are both at c over 2. So all we need to do is subtract this x value from this x value. So we need to take d over 2, subtract it from a plus b over 2. And we could combine those all into one fraction and say a plus b, subtract d, and that's all over the same common denominator, 2. So PQ, that length, is whatever a plus b minus d would be. Now we also need to find half of OA plus CB. Well, those ones we already found. CB was b minus d, and OA was just the length a. So OA, we just plug in the value of a. CB, we plug in the value b minus d. And now we can notice we're taking 1/2 times all of this. Think of this as a fraction over 1. Multiply our numerators. 1 times all of this doesn't change. 2 as a denominator times 1 means that our denominator becomes 2. So this would be our new value of 1/2 OA plus CB. And it is, in fact, the exact same. This piece right here is the exact same as this. So this is just a coordinate proof that any mid-segment right here is going to be half of this one plus this one. And that'll conclude our videos.